Alright, let's take a look at problem 37. It says, on the set of axes below, solve the following system of equations graphically for all values of x and y and state the coordinates of all the solutions. So, what we have here is a parabola and a line, and of course they can intersect at most. There can be at most two intersections, one intersection or no intersection here. But if there are any intersections, those would be our solutions. So this is an excellent problem where we can use a graphing calculator, but we also have to clearly illustrate our graph on this grid right here. What I'm going to do is I'm going to start with the easy one first. The easy graph to draw is the line y equals 2x plus 3. Now, do you remember the point-slope form of the equation of the line? I'm sorry, the slope-intercept form. Slope-intercept form is y equals mx plus b. And this tells us that m is the rise over run, and b is your what? B is your y-intercept, where the graph starts on the where the graph intersects the y-axis. So in this problem, m is equal to 2 over 1, which means we're going to rise 2 and run 1. Where are we going to start from? We're going to start from the y-intercept b, which is 3. Okay, we can see that b is 3 and m is 2. Alright, so let's go ahead and mark 3 on our graph. 1, 2, 3 on the y-axis. That's where you begin. You rise 2, 1, 2, and run 1. Alright, so those 2 points define the line. Let's graph some more points for accuracy purposes. Rise 2, run 1. Rise 2, run 1. Okay. Fold 2 back up 1. Fold 2 back up 1. Alright, and then just draw a nice line here. I'm going to be graphing this with a graphing calculator momentarily, but this is very easy to draw by hand, so I might as well take advantage of that. But it's a different story, of course, with the parabola, which is a little bit more complicated. Okay, so there goes our line. We have the line drawn. Let's label it. The equation of this line we just drew is y equals 2x plus 3. Okay? All right, next thing we have to draw is the graph of the parabola. Now, had it been we do not have a graphing calculator, there's a little work that has to be done to find the points, the necessary points. We have to find the vertex, the intercepts, the zeros, and then also where it intersects this line. Okay? Well, since we can use a calculator, let's take full advantage of that. So let's go ahead and graph this parabola right here. And I will also graph the line, but let's graph the parabola first. So we have, let's go to the graphing menu. We're going to graph x power 2, x raised to the second power, plus 4x minus 5. Enter. All right, and then let's graph it. All right, I had a statistical zoom, so zoom 6 will give me the standard graph. All right, so there goes the graph. Now, how do I replicate this nice curve on our coordinate grid right here? How do I replicate it? Well, I need to just find a few points. First point I need to find is the vertex right here. Okay, how can we find that? Well, we can think of that as the minimum, so to speak. How do I know that that's the minimum? Well, this is a upward facing parabola, and this is the lowest point, so we can call that the minimum. Why do I have to know the name? Well, we're going to use a special function in the calculate menu, so go to second function, trace. You see that right there, the minimum, that's what we're going to be looking for. So go down to option 3, enter. It asks for the left bound, which is a point to the left of your minimum, because there could be multiple minimums in this graph, but this has only one minimum, so it's going to be easy. But you might wonder, why do I have to do this? It's because of the possibility of more than one minimum. Okay, so go to the left of that minimum, see the cursor highlighting the points, any point to the left, you press enter. The arrow points to where the minimum is located, and it asks for the right bound, so you move your cursor using the right button to any point to the right of your minimum, press enter. So the two arrows are pointing to where the minimum is located, and it says guess, press enter. Boom, there goes your minimum right there. So it's basically -2 and -9, okay, because this goes on and on forever. So -2 and -9 is where your minimum is. X equals -2, 1, 2, and then 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is just for cosmetic purposes. Now, next set of points we want to draw are the points where the graph intersects the line. So how do we figure that out? Well, we have to graph the line also. Okay, so the line is 2x plus 3. 2x plus 3. Enter. Let's go ahead and graph it. Okay, and another thing you also want to note is that at 1 and 1, 2, 3, 4, 5, 1 and -5, we have the zeros. So we can also graph that. That's not really critical, but it's good to take advantage of that. We have a point here at 1 and 1, 2, 3, 4, 5. Okay, but the most important points that we must graph are the intersection points. If you want to get full credit, you must clearly state where those intersection points are on the two graphs. Okay, so pay close attention to this. We're going to calculate, second function calculate, intersect, option number 5. It's gonna ask you for the first curve and then the second curve. The reason it does that is because you could have more than 2 curves here, but we have only 2, so there you have it. All right, so let me do something again. So one thing you want to note is that when you're doing when you're calculating the intersections, calculate intersect. Since there are 2 intersections here, you basically move your cursor to the a point close to the intersection that you want to calculate. Okay, so let's say we want to calculate that intersection first. So when it says first curve, you move your cursor to somewhere close to where the intersection you want to calculate is located. Press enter. And then it says second curve, make sure your cursor is close to where the intersection is. Press enter, it says guess. Press enter. And you can see it's 2, 7. 2, 7 is the second intersection. So let's go ahead and indicate that on our graph. So it goes through 2 and 1, 2, 3, 4, 5, 6, 7. Right there. Let me graph these points in green so that they stand out. So we have a point here, a point here, a point here, and a point here. So this is one solution, 2, 7. That's important. You must state the point of intersection. The next one is going to be somewhere here. Let's go ahead and figure out what that is. So second function calculate again, intersection, option 5. First curve, please move your cursor to a point close to where the intersection point that you want to calculate is located. Right there. Press enter. Second curve. Enter. Guess. The second intersection is at -4 and -5. Okay, so let's go ahead and graph that. -4, 1, 2, 3, 4. -5, 1, 2, 3, 4, 5. Right there. So you see the points that define our parabola? You should see it, so let's go ahead and connect the dots. So this is a parabola right here, goes through there, and then through that. Oh, this looks terrible. Through there like that, and then the other one goes something like this through that point. If you do this by hand, it should look much better than this, what I'm doing right here. Okay, so this is basically what it looks like, and we must indicate where the second point of intersection is, which is at, remember, it's -4, -5. All right, so it says we should state the coordinates of our solution. So let's go ahead and state the coordinates of our solution. So right, it's on the side, the coordinates of the solution. Solutions to what are we solving? Systems of equations to the system of equations are -4, -5. That's the first point of intersection. and 2, 7. Okay, so you don't just graph it, you must clearly state what the solutions are. It basically indicates that you understand what you're doing. Okay, and then we have to remember that this blue line right here, the equation of this line is y equals x squared plus 4x minus 5, actually on the line of this curve. It's x squared plus 4x minus 5. All right, so that's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for updates to other cool clips such as this. And do post a comment to let us know what you think about this clip. We really appreciate it. More clips can be found on math.serve.com/testprep. Thanks again for watching and have a wonderful day.